Hello everybody and welcome back. We have here on the bench a Gyruss PCB set. It only has a standoff here and over here, so it's kind of not very good like that. Got a couple pads that are burnt and I don't like that repair job, so I'm going to redo that. That's like lifted up, you know. It's just that needs to be fixed. That's an edge connector wrecker right there. It looks really dirty, but it don't look terrible. I mean, this cap looks like it's broke or something. I think the first thing I'll do is take this board off the top and do a little bit of inspecting and see what we got. See what we're working with here. Okay, just looking at this guy, it looks complete. It is complete. It's got all of the Konami customs. They even scratched off the 2114 RAM. They didn't want you to know those were 2114 RAM chips, apparently. I don't know. That's weird. But that's what those are, 2114s that are not accessible by the Z80, which they've got that scratched off too. But that is a Z80. That is a Konami custom there. This is a Konami custom. That's the Konami 6809 clone type deal custom chip. And then there's some basic other customs, and I do have these customs, so I got a board that I can test all these custom chips in. Make sure that they're good. And over here you got 4 of those A93Y whatever 8910s or whatever the hell they are. The synth chips. There's like 4 of them. I think they're all right here, and then these are Z80s, I think. The Z80s might be up this way, though. I'm not sure. But I know there's maybe 1 Z80 and 5 of those chips, or 2 Z80s and 4 of them. And then this, I don't know what this is. That's another custom, I think, that we just hope is good, because I don't have no way of... I don't have one of those. So that's pretty much it. So I think what we'll do is hook this thing up and just go ahead and fire it up and see if it does anything. You know? Why not? Everything's in the right way. Pin 1, wise. Pin 1, pin 1, pin 1. That doesn't mean it always has been. These could be dead. These could be cooked. Okay, yeah. Alright. Alright. And that will be the first order of business. I have a super basketball board that I can test most of these custom chips in. So I can do that if need be. So alrighty. First things first, what am I going to do? Let's just hook it up and fire it up and see what happens. See what we get. Okay, almost forgot I had to do this. Before I use my edge connector on this, I redid this, made it flatter, kind of cleaned this up, scraped it out, cleaned it with alcohol, make sure you get a good stick on it, and then just tack solder it down. That's what was going on with this thing, is they had solder really piled up on the track. They used copper tape, but they really soldered the heck out of it. So I redid it, and it's good to go. So now we can hook it up and fire it up. Okay, we are hooked up. I'm set to monitor 5 volts. That is red to red. That's good. Hooked up here, hooked up there, parts to parts. Back here we are solder side to solder side. Good to go. turn this off. And let's fire it up and watch our power. 5.15. I'm gonna dial that back a little bit. There we go. 5.02. And oh, let's shut it down. So we got our board power right. Yeah, let's plug this in. The 100-volt Nintendo outlet. Okay, that's good to go. Now let's do that again. And it's on. See what we get. Well, looks like it's just graphics problems. That to me just looks like 2114 graphic RAM. I guarantee you. Well, I'm not going to guarantee it, but I bet you. I bet that's what it is. I don't know. Do I have my joystick, the Atari joystick, hooked up to this? I don't think so. All right. Well. Huh. I guess test doesn't do anything. We don't have test hooked up, do we? Yeah, I do. I do have test hooked up. I'm going to try to restart. Apparently that's not test. How about this? Let's try restarting again. What does that even say? Huh. No idea. Okay. I am suspecting these 2114 RAM right off the get-go. That's what I am expecting. And since those are untestable with the fluke, you cannot get to them with the fluke. That cap is busted right there. I'm going to pull all these, I'm going to socket them. In process of elimination, I'm going to go through them one at a time. Kind of got to do that because, yeah, you kind of have to because I can't test these. I can't test them with the fluke. So, and the Z80 is soldered into the board, and I don't really feel like removing that if I don't have to. So, right off the get-go, I am going to socket these, pull them, socket them, and put some known good RAM in there. See what happens, and then go through these guys one at a time and find out which one of these is bad, because I'm pretty sure it's one of these. Alright, so let's do that. Okay, it turns out I think we have two issues. I'm pretty sure we have no sound. No sound at all. So, that's interesting. We got a problem on this board too. And then we're going to do the video part on this one. Let's fix the video first. Let's get this looking right first, and then we'll worry about sound. Alright? Alright guys, I actually took the time to, I reset everything. Every socketed chip I reset. These 3 custom chips, I cleaned the legs. Those are the silver plated ones. I got them cleaned up. I'm going to dry them good and then put them in the board. I took a minute to wire in coin and start inputs. Coin and start, I wired those. And I got ice cream. Here's a little game we can play. What is everybody's favorite ice cream? Leave in the comments your favorite ice cream. Mine is butter pecan. Let's see what everybody's favorite ice cream is. But I'm going to dry these guys off, put them back on the board, put it back together, and see if it does anything different. Probably won't, but you never know. And then if that doesn't work, then we'll move on to the original plan of removing these guys. Alright. Comment below. Ice cream. Okay, guys. I did socket and replace these guys right here. And when I removed these rams, I bounced all around doing them so that I didn't overheat them, because if they're not bad, I'm going to put them back on the board. And this is looking like there's more to this than just bad RAM, because this is the enable pin right here, enable 10. And these are never enabled. And this guy right here, I believe the 245, which communicates out on the bus from this guy and back, is this 245. And if you see right here, this, I believe this is probably the side that's connected to the data from this guy. And it all looks good, you know, right down the line, they look good. This is the enable line, it's always enabled. And this is the direction line. This is kind of curious. The direction line is always one direction. So this is never, it's only sending something one way and not the other, which is kind of funny. So I'm going to have to get the schematic out for this and start looking at that section. Look at this guy, the control signals for this. Because I think this is a control signal problem. I think I'm going to continue just poking around a little bit and poke around on the Fujitsu parts a little bit. There's Fujitsu all over this board. Yeah, so that's the plan of attack. A little bit of poking around, and then I'll have to go to the schematic, track down these control lines. Just going to be poking around here a little bit. You know what, it might be better to, let me try over here, guys. Let me see if it's better over here. Move that box. Yeah, this way I think I can move this down and you can get a better look at the scope. You can at least kind of see what I'm looking at. Anyway, just keep poking around here. There's two 367 bus chips, you know, and they're never enabled, which is absolutely weird. Why would these never be enabled? That's got to be a problem. That's never enabled. And then this custom CPU, remember that direction line I talked about? That direction line is always going one way, it's always high. So this thing, maybe it's never receiving anything. It might be, you know, I don't know. I'd have to look at the schematic to find out what is really going on here. But I know it can't communicate both ways. I know that because it's only going one way. That's pin 10 of the RAMs. They're never enabled. Those are the Sprite RAM that are never enabled. These 2148 RAMs. They look okay. That's good. Yeah, we got no sprite action at all. We're missing control lines. I don't know where they come from because I need to look at the schematic to find out where all these things are coming from. This is just poking around and finding weirdness, you know. Just kind of jumping around the board. we got some good stuff to investigate. Yeah, we got some good stuff to look at. We got some good answers. We got some good questions that need some answers. Why are these RAMs not being enabled? Why are these 367 busing chips, why are they not being enabled? Why is this only going one direction, this 245? Those questions will hold the answer that fixed this board. So we're going to have to answer those questions. The 367s, why are they not enabled? Why are the RAM not enabled? And why is this only talking one way? We answer those and we'll fix the board. So I'm going to have to look at the schematic and go from there. Alright, I want to show you something I found. This guy right here, 18E, the low side of 18E, which is right here. You know, the data is QDB0, whatever that is, and then, you know, the clock is Q1R0. And preset and clear are always high. It's not resetting. So we should have, you know, an output on Q come down and is the preset to this guy. And data is always low. So when this presets, it'll preset that to high, and then 816 will clock it low immediately. That's what creates the toggle here. Now if we come over here, and I also want to point this out, that makes the signal I0 or IQ or 1Q or whatever that is. That, if we come over here and look at this 42 pin custom, one of the control inputs is that IQ or I0, whatever that is, 1Q. So if we come over to the bench, and let's look at that high side of 18E here. Here's pin 1, which was that reset. And you can see that I do have it jumped. And this is the data. This is the clock. This is the input, or the output Q. And this is Q not. Let me get on it. That's, you know, it's the inverse. It's low. Now what I've done here is I've jumped a 74 over that chip, but I've lifted the output legs. So if we look at the original chip that's in the board, Q is high. But if now I'm touching the leg here. See, if I just keep it on the actual chip in the board, Q is high. But I can put my probe on Q of the jumped chip. You see that? That's what that signal's supposed to be. That's supposed to be the preset signal to this other side of the chip. So this thing, all of the outputs of this thing are all high. This isn't doing anything because that signal is not enabling this guy. So I need to replace this flip-flop. So I'm going to stop, turn everything off, and replace that guy right there. Okay, I also wanted to go over, remember I was saying that the RAM, these 4 RAM chips right here, see how it says 2114 times 4. Pin 10, remember pin 10 was not being enabled. It is X right and Y right. See it? Those two signals are up here. X right, Y right from this 139. That gets enabled by this 32, which gets a signal. See, this 803 is always toggling, but this signal is always high coming off of this guy, this 138. So if you have an OR gate and one of them is always high, then the output's always going to be high. So those will never be enabled. So you'll never get those two signals right there. So you have to backtrack. Oh, why is this always high? Why are these never being enabled? So you probe these two inputs and you find that this one's always high. This one toggles, 13 toggles, but 12 is always high. So you have to say to yourself, this has to have a purpose. This 32 has to have a purpose. So this always high input has to be wrong. It has to toggle for this thing to do anything. So you got to come back and you get to this 138. And I probed all of the pins on this. 4 and 5 are tied low, so they're always low. That enables that. Those are just enables. And pin 6, this enable is toggling. So, and 1, 2, and 3 are always high, nothing but high. So that's binary. That's 7. This is selecting 7. Which is up here, and 7 is always low. And that is just always enabling this ROM. It's just stuck low. But this part is not bad because it's doing what it's supposed to be doing. These 1, 2, and 3 are not toggling at all. So you're not getting any variation of outputs out of this thing. It's always just pin 7 is always low and the other ones are always high. So then you got to say, why is 1, 2, and 3 not doing anything? You go, because those are the select lines. 1, 2, and 3 determine what goes low, you know, but anyway, 1, 2, and 3 not toggling is a problem. So then you'd follow 1, 2, and 3 down and it comes to this 244. So I probed the 244 and the 244 is doing exactly what it's supposed to be doing. Everything is high. The ins are high, the outs are high. There's no toggling at all going on. So I'm like, okay, there's something going on with this 42, so I got to check these control signals. So I checked pins 17 and 15. Those are the E and Q clock on a 6809, and that's what those are. They're 1.5 megahertz square waves. Those are the clocks for this thing, because this is a version of a 6809 processor. And then I probed 11, 14, and 16, and those were all toggling. So those signals are good. Then I come down and I probed reset. Reset's always high, so it's not resetting. It's not stuck in reset. And then here's this 1Q or whatever, which isn't doing anything. So I'm like, okay, that signal isn't doing anything. So what's up with that? I got to find that signal. That's what led me up to here. That's what led me to this guy. So that is what I'm getting ready to replace right now. Well guys, as you can see, I have resorted to the fluke. I had to remove the Z80, put a socket in there, and all of my memory stuff is fine. I replaced this chip and it didn't do anything. Don't you just hate that when you think for sure you've found the problem, you replace something and it doesn't do anything? We're still funky. We still funky up in here. Yeah, so I don't. Yeah, it's a whodunit at this point. It's something that is not CPU related. It's in this area. I guarantee it's got to do in this area. Some kind of a control signal. I'll just have to keep on poking until I find it. But I wanted to just go ahead and eliminate video RAM, any of that kind of stuff, which I don't believe it would be that, because I would expect this stuff, the junk on the screen, to be kind of not so static. There's nothing going on. Like there's no clocking going on. Ooh, no clocking. I have to check that out. Check into that. Yeah, so the search will continue. And then we got to deal with no sound on top of that. So, the fun one. All right. Okay, cutting back in because I found something kind of fishy. I am analyzing the signals on this 367 down here, and I'm going to show you what it's doing. It gets this is the enable line up top. The second line is the input, which the input is from one of the customs, and the input's fine. It's the output that is weird. Now when this thing goes enabled, goes low, this does what it's supposed to do, and so the chip itself is working, but this is part of a bus. This is part of a data bus. There's nothing on that data bus, and when this enables, then it's sending a signal. But as soon as this disables, there's no input here. It's just floating. Yeah, so it's really strange. I got to find this data bus. This is, and I'll show you. I'm on pin 2 out to 3 of 10F. 2 out to 3 of 10F, and we want to know what bus this is. 10F. So we'll come over to the schematic and we find 10F. Pin 2 out to 3. 3 is what we're concerned with because it's this Q data bus bit 4. Pin 3, see? That floats until this thing enables. So this chip is actually doing what it's supposed to do. But the concern is Q data bus 4 has no activity on it until this thing enables. And now I come over here and I find all these QDB bits. And I imagine that this is connected to this bus. It just doesn't show it. So I want to look at these parts. This 245 here. This guy here, this ROM, everything that's connected to this data bus, something's funny. Yeah, I don't know. So I'm going to start poking around this area right here. See if I can find anything out. Okay, I started looking at 19E, this EEPROM. Pin 16 is connected to our bit in question. Pin 16 is QDB4. And I think that ROM is what creates is what starts all of this. You know, it comes out of the ROM and it goes there, it goes here, it goes here, it goes everywhere. If there's nothing out of the ROM, then that stuff, it'll float, which is what I'm seeing. And if I come back over here, I'm just checking continuity between everything, and I am beeping out, like, this is Q data bit 4, and it goes to pin 5 of this guy. It goes to, what is this, F, 19F? No, that's that guy. It goes to 14C, which is this guy. It goes to pin 14, 11, 12, 13, 14. It goes to 12C, pin 14. Okay. It goes to 14E. 14E. 14E, pin 15. Okay. And remember that ROM that it starts at? It starts here on pin 16. There's 14, 15, 16. No continuity. Now, you can get on the socket. See that? If I press, now I'm on the socket itself. But if I just get the chip, there's no continuity. If I remove the EEPROM and I just go to the socket, no problem. So we have a bum socket. See how that one on the end, hold on one second. Okay, let's try that. They both look about the same. The bottom line is there is no connection to that pin. So I'm going to replace this socket. Be right back. Guys, just for giggles, I barely put this in the socket. You can see how it is standing up out of the socket. And then I checked and I was like, okay, now I have continuity on that leg. All of that over one bad socket. So yeah, it just goes to show you these sockets can cause a big problem. All right. Yeah, there was your culprit right there, the floating data line. There's just no data on that bit, and that one bit messed up everything. Now, I'll be honest with you, that's just one of the legs on this. There could possibly be more. I don't think so though, because that's the only one I saw floating. So yeah, it was just one line. One data line floating screwed up the whole thing. Killed the whole thing. So yeah, craziness. So what I am going to do, I'm going to replace this socket right here. And I am going to test those RAMs that I pulled. And we'll be back. I bet you every one of those RAMs is good that I pulled out of the board. So I'll be back. Let me go ahead and replace that guy and we'll be back. Okay, I have found something, guys, that is pretty fishy. This is 2C on the soundboard. It's a 367. Now if we come over here, and I'm hooked to pins 1 and 15, those are the enable pins. Okay? Those are the enable pins, 1 and 15. So if I come over here and I look at 2C, 1 and 15, see that? 1 and 15 are connected. They're the same thing. 1 and 15, there's 2C there, and there's 2C there. Pins 1 and 15 both come off of 33, IN6, IN5, 14, 2A. It's interesting as this looks like two separate. The schematic is showing that 1 and 15 are connected here. But then at the same time it's saying that this signal is coming from pin 10 out to 9 on 2A, and then down here it's 2A 14 out to 13. It can't be both. So I'm thinking that one of these is for pin 15 and one of them is for pin 1. But it's got them shown as connected. That is got to be a schematic error. Has to be. 2C, 2C. Pin 1 and 15 are both getting inputs from two different sources. That just doesn't seem right. I think what I'm going to have to do is do some beeping out and see what's going on. Be back. Yep, guys, that is absolutely a schematic error. This is pin 15 of 2C. It gets its enable from pin 9. According to the schematic, pin 9 and 13 of this chip should be connected together. There's 9, 10, 11, 12. There's 13. Now 13 is the enable for pin 1. But it is not connected to pin 9. So yeah, that's definitely a schematic error. So yeah, keep that in mind. So with that in mind, I'm going to re-look at this. I'll be back. Alright guys, do a little hanging out here. Hanging out and probing around. I printed off a schematic of the soundboard and it's in 4, quarters, and I tape it together. I cut it good with a, whatever you call those, and taped it together good, trimmed off the sides, and got a perfectly square Gyruss soundboard schematic. So I'm starting at the very beginning where the sound enable comes from this board over to here. And it goes into pin 14, pin 14 of 4D. Pin 14 of 4D. You see that flashing? I don't know if you can see that. That is flashing. And this is, it does not say that it's enabled low. It doesn't have a bar over it. It just says sound on. But I know that this is enabled low. This is an active low signal, because when it goes to where there's no sound, now it's just high. There's no enabled sound now. That's pin 14, and it goes through to pin 13. So now there's sound. You see it's flashing. Here's pin 13. I think I reset it or something. But once it gets into gameplay, I'll let you know. I don't think you can see the screen. It is now in gameplay and it's flashing. So this 367 is working. And then that goes to 5D, which is a 74 flip-flop. That's right here. That signal clocks that on pin 11. So 8, 9, 10, 11. There's that clock. There's that sound enable. Okay, and the data pin is pin 12, which is just held high. That's tied high. So how this works is, data and the preset on pin 10 are both tied high. So what gets this thing's outputs to toggle is the clear signal on pin 13, which is right here. And there's no gameplay right now, but when gameplay starts, this should toggle, because that's what's going to clear the interrupt. See, there's no toggling, which means that this isn't doing anything but staying high. The data is high, so Q will always be high, Q bar will always be low, and Q bar is the interrupt signal for the Z80, which is right here. So this Z80 is always stuck in interrupt. That's why we don't have no sound. This has to flash. So I have to trace back. I mean, the flip-flop's doing exactly what it's supposed to do. So we have to trace back. And we have an O2 at 6D, which is right here. And that is providing that clear signal. And it gets inputs from pin 6 and pin 5. So pin 6 is low all the time. Which that comes from, pin 6 comes from, it's the output of an O2 where reset is one of the inputs and the other input is tied low. So if reset is always high and then the other input is tied low on a NOR gate, the only time that will be 1 is when they're both 0. And they are not both 0 because reset is high. So that is going to be low all the time. So that input's not a problem. Now we go to 5. And 5 is low all the time. That comes from another LSO2. It comes from the same LSO2. You know, that input comes from the output of pins 2 and 3 out to 1. But a 0 and a 0 is a 1 on a NOR gate. So that gate's actually working as it should. Okay. So let's go to 3 and 2 out to 1. See what they're doing. 3 is toggling, and 3 comes from I don't know if MI is an output of the Z80 or it's an input. I think it's an output of the Z80. And pin 2 is also an output of the Z80. And pin 1 is low all the time. That's kind of suspect. You got pins 3 flashing, pin 2 flashing, and pin 1 is always low. Now of course that could be the way that that's working, but the only way to find that out, and that's just a 2 input gate, you know, 2 inputs 1 output. So I can go ahead and use my Regal scope, put that on there, and we can look and see if that thing's working right or not. So I think that's what we'll do next, is we'll check that gate, pins 1 and 2 out to 3, and that could be our whole sound problem right there. So let's do that. Okay, remember I said that pin 3 and 2 out to 1 wasn't toggling, and it seemed kind of suspicious, but it might just be that way. Well, it might just be that way. This is a NOR gate. The only time you'll get a 1 on the output is if both inputs are 0 at the same time. And I've taken multiple snapshots of this, and they're never 0 at the same time. So this is actually working the way it should. So these 2 signals right here are Z80 sourced, Z80 made signals. So I'm starting to wonder if this is a software problem. So I am going to take these 2 ROMs, these guys, and I'm going to take this guy, and I'm going to verify those ROMs. Because the only way that I believe these are going to line up at the same time to be low to trigger that interrupt, it's got to be software driven, right? Either the Z80 can't access the ROMs, or, which I could just remove the Z80 and put the fluke on it, which I probably will. But first course of action, I'm just going to test the ROMs out. I'm going to put them on my reader, dump them, and see if they verify. So that'll be the next step. Okay, I just got done doing some ROM verification and everything, and what was really weird was this ROM dumped and verified to the actual Gyruss file. But when I had my fluke hooked up to this, I would get just random nonsense out of this guy. So I burnt that file and put it here, and I put the fluke on it, and it verified, read it good and everything the way it's supposed to be. So that's good now. The RAMs are readable. So that's good. But we're still not having any sound, even though this ROM is definitely, I don't know, it just doesn't work. It's weird that it verified, it dumped and then verified on ROM-ident to the ROM it's supposed to be, but it's no good when you put it in the board. So I burnt another one, and now we are good to go there. This is the proper files and everything. The Z80 works with them. And yeah, so. You know, I guess I got no sound still though, but I don't know. I could try putting a different Z80 in it. I don't think that'll work though. I don't think that'll make a difference. But it might, so it's worth a shot. I'll try that. Okay, there's 2 138s on this board. One of them is right here, and the other one I'm on. The one that I'm on is this ROM selector up here, and I already know that's good because I was able to select all the ROMs when I had my fluke on it. But I wanted to look at this guy, make sure it was doing the right thing, and it was. Nothing fishy. But I just kind of wanted to show you what that looks like I got a snapshot here of it. If I can, let me move this out of the way, get a better picture. And let me disable the touch screen. I've got it, you can see this, I got this labeled enable on 1. So whenever this is 1, this thing is enabled. And then I've got select, and then I've got all the outputs labeled. 0 out, 1 out, 2, 3, 4, 5, and then 6 is down here a little bit. So you can see it's enabled and it's selecting 0. Seems like that should have been 0 right there. But anyway, 1, 0, and 1, and it's selecting 3, so 3, output 3 is low in those two spots. 1, and it's selecting 0, 0 is low. 1, selecting 0, 0 is low again. So it's working. I think that's just an anomaly up there. Let me take another snapshot and look at it. 1, 1, yeah, it's selecting 0 the whole way there. Here's some more 3s and 1s. These should be 1. It doesn't say, but yeah, it's either 1 because those are enabled. So this thing's working right. That's how you look at that, though. But yeah, so those 138s are good. This, I'm afraid this processor might be bad. Either this is bad, or so I'm not finding anything else bad really. But I'll keep looking. I will definitely keep looking. I'm going to look at these clock chips up here. These guys right here. Count chips. Just make sure they're counting. And just kind of poke around this board until I find, hopefully, what's going on with it. Alright guys, I have found something quite interesting. Kind of a logic probe comparison here. Look at this guy. I'm going to probe the data latch, which is right here. All of the inputs look great on the data latch. Well, let's just probe around on this with this. Okay, this is the clock, and it kind of sparingly does its thing, but it does do its thing. This is an output. And I'm telling you. Sorry about that, guys. I was got a little disgusted because I'm doing a logic probe comparison, and this thing was flashing like it is now. This is output, and this thing flashes. This is an input, input, output. See how that output flashes? Output, input, input, output. See, all of them outputs are flashing. This one doesn't flash much. Out, in, out, out. Now this logic probe, the loud one, check it out. This is your clock. Right? Out, stuck low. In, out, stuck low. Stuck low, output. In. Now this output is fine. This output is actually, if you look at that one with the oscilloscope, you'll see a nice up to you know, 5.75 volts I saw, or 4.75 volts. So this is a good signal. But look at these other outputs. That one is reading 2.3 volts at the max up here. Input, input, output. 2 volts, 2.2 volts. Output, 2.2 volts. Peak to peak. Now, this guy tells you it's stuck low. This thing has a different threshold. There's a clock. Output, low all the time. In, out, low all the time. Whereas this guy will flash. There's nothing wrong with that signal. I'm sitting here probing this with this logic probe, this whole board, thinking I cannot figure out what's wrong with this thing. Everything looks good. This is flashing. Looks like we got data going on. If I take this output bit and just short it to this clock pin, I'm going to remove this. It's something that is, something's on that data bus. See, it's on this side of the bus. It's not the Z80. I know the Z80 is good. I know the ROMs are good, and I'm pretty sure the RAM's good. So it's either this latch, or it could be this latch pulling it low. It's something attached to here. I think it's probably this data latch. It's either this guy or this guy. Would be my guess. One of these two guys. I'm going to start with this guy right here, the one that we were just probing. So I'm going to remove this guy right here, and we'll see what we get. Alright guys, well, I removed everything other than these ROMs. So I verified these ROMs are good. I removed the RAM out of the board, even though they verified as good. I removed them from the bus. I removed all of the 8910s from the bus, and I removed this remaining latch, which is this guy right here. No, it's this guy. I removed that guy. This guy's already been replaced. I just removed that, the RAMs, and all of the 8910s. And if you now look, I just got the RAMs or the ROMs are the only thing dumping data right now to the CPU. That's the only thing communicating. And if I look at them same data bits, now look at them. That's what those are supposed to look like. Yep. Voltage peak to peak upwards of 5 volts. So I'm going to just start repopulating one thing at a time. I'm going to put a brand new latch in here so that takes care of that. I'll put the two RAMs in here. As a matter of fact, let's turn this off. And let's put those two RAMs in right now. Yeah, let me cut away really quick, fix these legs up, and then come right back. Okay, I got the RAMs back in the board, and our data bits are still looking 5 volts. That's out, in, out, out, in, out. That's an out, in, out, out, in, out. Yeah. So now our data is looking awesome. So I will solder a brand new, what is that? 374. A brand new 374 into the board right here. And I imagine that'll be fine. And our problem is going to be one of these 8910s. So I'm going to socket all of these. I'm going to go ahead and do that right now. I'm going to put this guy in the board, and then I'm going to put 5 sockets in the board. Be right back. Found the bad one, guys. Is this guy. I don't know which position it was, but this is the one that was holding all of them things down. You see? Look at the data. Data bits, that's what they're supposed to look like right there. If I put this guy in there, they go right down. Let's do it. I'll shut it off, put this guy in. Remember, that's the bad one. So now and that'll totally kill the sound. It just drags all those data bits below the threshold where they just don't register. You were supposed to have music right now. This punk is messing the whole thing up. I do believe I have one of those. So let me turn this off. Get this thing out of here. Fold the legs over and throw it in the trash. Bye bye. And let's come over here. 8910s. I'm sure I have 8910s over here. Sound amps. I think I might have them in my sound amps. Yep, there's one right there. 8910. Right? Yeah. Boy, I don't have my glasses on. I can't see. But the game is shut off. And we'll put this guy in there. Just make sure 8910. Yep, 8910. There she is. Alright guys, I'm gonna set up and we'll play a little bit of Gyruss with the lights off. How about that? Okay, well I can't see what I'm doing. Let me coin up. I'm gonna turn that off too. I don't need that scope anymore. Coin. And I ain't very good. Come on. Kill something. All right. Oh. Game over. Well, guys, there you have it. Let's fire the lights back up. And let's grab this guy, shake you up a little bit. There it is. Gyruss. Gyruss. Good to go. Alrighty then. Alright, well, we had a bad socket right here. Remember, that was causing the flakiness on the star back, the background, and all of the sprites were killed by that socket. And then one of these 8910 guys was bad, killing the whole sound. So, yeah. Alright guys, Gyruss fixed. If you are not subscribed, please consider subscribing, because I'm always coming out with new stuff like this and trying to help the community, you know, by providing some insight and keeping old games alive for those who just don't have the means to do it. And I enjoy it, I really do. So, alright, I appreciate it, everybody. We'll see you on the next. Gyruss.